I'm going to cover a couple of key solvers to kind of demonstrate my today's lesson. So let me open this up here, and let's see. I'm going to use the slope and the comparison and the threshold. So I think these are typically probably the most commonly used solvers, and they also kind of best demonstrate what I want to explain today. So with the slope solver, right, you have a parameters section here that shows, that allows you to specify a certain slope requirement, right? So there's like a minimum slope and a maximum slope if you want to use two different slope values. And these slope values in here relate to this output section, right? So you can see these top two output sections are related to the max, which is the maximum slope right here. And then these bottom two, you can see in parentheses it says minimum here, and this one says minimum. And so these two output sections relate to the minimum slope setting right set here, right? And the same for the output in direction, right? In parentheses you have the max. So these two output settings relate to the maximum slope setting as specified here, and the bottom two, which have minimum in parentheses, relate to any slope setting or any slope requirement that you have right here. And the comparison solver has something very similar, except just whereas the slope, obviously you're looking at a slope requirement, and a comparison is simply you're measuring kind of the distance between two data sets, right? So with the comparison solver, you could be measuring the distance, say between this moving average and price, or you could be measuring the distance of the MACD to the zero line here. And let me I'm going to make this zero line a little bolder here so it stands out. So and I'm going to lock it and set that to 0 there. All right, so the comparison solver, as you can see, you have two different distance measurements that you can put in here, and so when the way these small amount and the large amount relate to the output, I guess the relationship shows up when there's an amount filled in here. So let me put I'll put one tick in there, and we'll put two ticks in there, and sometimes the values in here update instantly, and sometimes they don't. And if they don't update, then what I usually do is I just click on another solver and click back, all right, and that forces the parameters to update. So now you can see, right, so in small amount I have one tick, large amount I have two ticks, and now you can see the description of the output changes, right? So we have A greater than B by one tick and A greater than B by two tick. So once again, just as I showed in the slope solver, this comparison solver, these output parameters relate to the values you put in this different section. And so these two different measurement parameters allow you to control the output of the solver. And then another example is the threshold, right? So you can see we have thresholds A through B, and you can see on the output sections you have outputs based on the values of A through E. So so thresholds of A through E, and you have outputs A through E. And so when you're measuring your indicator's location, in relationship to either a threshold, right? So that could be like the 0, or if you're measuring your indicator in relationship to price, you can control the output based on that. So that's what I want to cover today. So so give me a moment here. I'm gonna clear out your guys' responses from my interface question. That way, if new questions come in, I can see that. And so I'm sorry, just to kind of get back to the interface question. So Randy was asking, he doesn't see a way, how you'd link them. So Randy, I don't want to get into any details because we haven't made any decisions about the details of how tabs will be linked, but essentially there would have to be a new node that represents the tab, and obviously that's not going to show up on the existing BloodHound. All right. So let me start. I'll start off with the slope solver and just kind of create some examples, and just create some examples to show how how the different measurement, I guess you could say this parameter section, it's a measurement, right? It allows you to select a measurement of the slope, and the comparison solver allows you to measure an actual distance, right? So you can measure a distance in ticks or a distance in points. Those are the two common ones. But of course you could also measure a distance in ATRs and the Renko bricks. All right, so the comparison solver measures distance, and the threshold solver, it's also, you could kind of say it's kind of a measurement of distance, because that's what you're specifying in here is really the threshold solver, you're kind of specifying a fixed scale of your indicator. So for example, the stochastics, right, it ranges from 0 to 100, and so you could specify any threshold value here between 0 and 100 to to measure the distance between the indicator and that threshold value, and then control the output that you want from that. All right, so back to the slope solver. So its default state is essentially 0 ticks, which 0 ticks is a flat slope, and the default setting for that is that so with the 0 slope, essentially you're just looking for the indicator to be either pointing up or pointing down by any amount. As long as the slope is greater, as long as the slope is not flat, then you're going to get an output from the solver. So as we can So as we can see from the chart, right, so we're looking at the white SMA line. And so we can see as soon as the SMA starts pointing down, we're getting a short output, right? So as soon as the slope of the SMA flips, we're getting, so here's kind of the next part of what I want to show is that we're getting a value of 1 on the output. And so actually I'm going to kind of take another step back and kind of explain what these values represent, because that's kind of another sticky point that new customers kind of have to get used to. So with solvers, we call all these solvers essentially confidence solvers. That's kind of their general term that we've given them. And they're called confidence solvers because what each of these solvers is trying to do is it's telling you the percentage amount of your condition being met. So for example, if we're just looking for the SMA 14, we're looking for essentially anything greater or less than a 0 slope or a flat slope. So as soon as the SMA points up or slopes down, essentially that the slope of that is met by 100%. It's greater than flat, and it is 100% confidence in that. And I'll give you an example here in just a moment. So actually here's an example right here. Here, let me stretch this way out, and you can see we actually have one bar here that is absolutely flat. And so there is absolutely no slope on this, and so there's no output from the solver. So it's saying that there's 0% confidence that there's any slope on the SMA. And then as soon as the SMA slopes down just by a fraction of a bit, then all of a sudden there's 100% confidence that there's a slope on it. And if you guys remember from high school math, right, 1 represents 100%. And 50% of something, if you have 50% of something, you have half of something. So 0.5 represents 50%. And right, so if I put in, actually I'll just set this to 0. So if I put in 0.5, that's basically saying that 50% of our criteria has been met. And our criteria is looking for a slope that's greater or less than 0 ticks or flat. So so each of the solvers inherently has built into it, the fuzzy logic component. And so the values that range, when your solver output values range from 0, meaning the condition has absolutely not been met, to 1, meaning 100% of your condition has been met. That's essentially what all of the solvers are doing. And so now let me start kind of creating some examples to help explain this a little better. So I'm going to start specifying a slope requirement of 1 tick. And maybe I need more. Let me put, actually, yeah, let me use 1 tick slope requirement. And there we go. And you'll notice that my The description field didn't update when I put 1 tick in here. So I'm just going to click on another solver real quick, click back, and now you can see my fields are updating. So you can see when I put 1 tick in the maximum slope, now we have an analog type output from this solver. And so what we'll do is so if we match up the output here, so essentially when the SMA is at 0 ticks of slope, in other words it's flat, our output, so when we're at 0 ticks, our output is 0. So when we're flat, there's no output. And then when the SMA reaches a slope of 1 tick, then our output's going to be 1 or 100%. And so if we look at this on the chart, let's see, let me change the, I'm going to change the plot style here because it makes it a little easier to visually see if I change this to, where is it, the hash. And yeah, I'll leave that 3. Okay, and so here's another kind of a concept that some people aren't quite grasping is, how do you measure slope? So I don't want to get too off topic, but it does kind of help explain how this is all working. And so what we're looking for is a slope of one tick, right? And slope, so when you're looking at the slope of an indicator, essentially you're just measuring the price difference or the movement in price. So when I look at the output of the slope solver, right, essentially this is, let me slide this chart over, right, so I can look at the output of the solver and it's at -1, or essentially it's at 100%. So what that's saying is that the SMA moved from this bar, so let me mark it, so from this bar to this, oh, let me get my arrow on there we go, to this bar, there we go. So when the SMA value from this bar to this bar, this price difference is 1 tick, right? So this is the CL chart, right? So 1 tick is a tenth, or I'm sorry, 1/100th. So it's a penny. So I can see that we went from 93.99 to 93.98. So the SMA moved 1 penny, or 0.01, which is 1 tick. So price moved one, or I should say the price difference on the SMA is 1 tick. And so that met, and so that's what our requirement is. We're looking for a slope of 1 tick. So when you're looking for a slope, so essentially the slope is just the amount of Y movement, and in this case Y is the price of the instrument. So if you're looking for a 1 tick slope, you're looking for the indicator from one bar to the next bar to move 1 tick. So that's what slope is, essentially. And so as soon as our SMA from one bar to the next bar, if it moves more than 1 tick, then that is saying that our requirement has been met 100%. So So I'm going to stretch this out so that way we can exaggerate the price movement on the SMA here. And so we can see if we're looking back a few bars, so if we look back one bar, the movement from this bar to the next bar, it is slightly less than 1 tick. And I can tell because the output of the solver is basically it's 71%. So what the solver is saying is that the slope of this, it has met our requirement of a 1 tick slope. It's met it by 71%. Right? So the slope here of the SMA is not quite 1 tick. It's just a little bit less. So only 71, so it's 71% of our 1 tick requirement. Right? And if we step another bar back, we can see that the slope of these next 2 bars is essentially, I'll just round it up, 43%. Right? So there's a 43% confidence that the SMA slope is at 1 tick. And so let me kind of go one step further here, and so I'm going to change my requirements. So actually, let's just say I'm looking for a really steep slope. So I want to be looking for when the SMA gets into a really steep rise. And so 2 ticks is going to be pretty steep. But I really am not interested in the slope of the SMA until it at least reaches 1 tick. So now my requirements are from 1 tick to 2 ticks, or essentially greater than 2 ticks. Right, so if we look at the output here, and I can see I'm having a tough time of getting my outputs to update. So let me just click on a solver and click back. So now we can see our output parameters are going from 1 tick to, and we can see here, 2 ticks. So we have at 2 ticks and greater than 2 ticks. So really, I'm not interested. So what I'm saying is that at 1 tick, our minimum slope is 1 tick, is that I'm really not interested in a slope of 1 tick. So I'm specifying a 0 output when the SMA slope is less than 1 tick, or even when it's at 1 tick. I don't care about a slope that small. I'm interested in really when the slope gets to 2 ticks. And so when I'm at 2 ticks of slope, then I want an output from this solver. That's when I'm interested. So my trading criteria says, tells me I'm looking for a really steep slope in this moving average. And then of course, if the slope gets greater than 2 ticks, then I'm still interested. So if we look and let's see if there's any cases like this on the chart. That's probably going to be the hardest part, is finding a steep slope like that. Here we go. Great. Here's a couple of areas where that's been met. So I'll stretch this out. And exaggerate the chart a little bit. So we could see here that the movement, so I'll use this guy. So from here to this arrow, the distance on our SMA here is 2 ticks. So this distance moved 2 ticks, therefore making a slope. Our slope is 2 ticks or more. And we can see that just prior to this, that BloodHound did give us an output, and so this output essentially is the confidence of the SMA approaching a 2-tick requirement. So if I step back 1 bar, so from here to here, it hasn't quite reached 2 ticks, but it's at, once again, 43% confidence that we're going to get to 2 ticks of slope. So the solver's output is saying that, there's a 42% confidence that we'll get to 2 ticks of slope. But it's also saying that we are greater than 1 tick. So remember, at 1 tick or less than 1 tick, there's a 0 output. But in between, so when we're in between 1 tick of slope to 2 ticks of slope, the output is going to range from 0 to 100%. So with the output here, with this output being at 43%, all right, so remember I'm rounding this off to 43% or 0.43. So what that's saying is that we're almost at halfway between 1 tick and 2 tick. So we're 43% of our 2 tick requirement. So we're greater than 1 tick, but we're a little bit less than 2 ticks. So for those of you who are good at math, I can tell that my slope of the SMA is 1.43 ticks of slope. So essentially I can take this 1 tick and then add this confidence value here of 43% or 0.43 and add it to 1 tick, and so the slope of this SMA is 1.43 ticks of slope. So that's kind of the general concept of how how these why the outputs, why we're using 0 and 1, right? 1 representing 100% of our condition has been met, right? So once again, as soon as we go, so back here, up here on the chart, as soon as we step forward 1 bar, and then we can see that boom, the SMA moved more than 2 ticks in its step down. So that's a 2 tick slope, and then essentially 100%, 100% of our requirement has been met, and so therefore BloodHound's output is at 100%. So this kind of gets into the, definitely this gets into the advanced use of the fuzzy logic when you start using multiple slope requirements. But at least if you kind of have at least kind of a grasp of what's going on, then that'll help you, it'll help you understand how all of these parameters and how the output relates to the parameters. That's kind of what the key concept that I'm trying to convey to you guys today. All right, so let's we'll move on to the next solver, and essentially kind of repeat the process. All right, and okay, so the comparison solver. So as I said earlier, what we're doing is we're measuring a distance between two data sets. And so in this case, you know, I haven't put anything in here. So let me, we'll keep this simple, and I'll specify the closing price to the SMA. And there, shrink those down. That'll stretch out our chart a little bit. And so we'll start with the basics, and I'll reset this back to 0 and back to 0 ticks. And so with this solver, right, you can see there's a long output and a short output. So you can get really detailed in controlling, controlling the output of this solver. So as we can see, this is kind of like the default setting of 0 tick amount, large amount and small amount being 0 ticks, and the default output, and I can see the description field didn't change, so let me check that real quick. There we go. So what we're looking at is when A is indicator A, which is the closing price. So when the closing price is greater than B is our SMA, by 0 ticks, we want, we want an output, or we're going to get 100% confidence. So that's just when A is greater than B by 0 ticks. And then if A is greater than, when the closing price is greater than the SMA by 0 ticks or more, then once again, we want 100% output. And the opposite is true for the short side. So when the closing price is less than the SMA by 0 ticks, we want to know that as well. And so to help this, to make it easier to kind of see what we're comparing, instead of using a bars, I'm going to just use a line. So let's just, let's see, yeah. And I need to take that black off of there. And we'll put it back on orange. All right. Okay, so there's a line chart looking at the closing price only. And actually, I want to make this visually easier to see. And box, no. Let's see. It'd be kind of nice if I could put dots on the actual price value. I'll do a little trick here. I'm just going to put another SMA on the chart with a period of 1, so that with a dot. That way it'll mark the actual closing price value here. So I'll set this to 1. This is on orange. Good. I'll make my dot a 3. There we go. Great. Great. So now we have a dot representing the closing price, and so in the comparison solvers, default settings of looking for a zero difference, a zero difference requirement, zero tick difference, right? Remember the comparison solver is measuring a difference between the indicator A data set and the indicator B data set. And so in the default state, we're just looking for when the closing price is below the SMA by any amount or above it. And so now we can start. So now if we start putting some requirements in here, so let me kind of find something. Yeah, I'll do something simple here to keep the math simple. So I'll look for a 10 tick amount difference. And let me click on another solver here to get the output to update. And so now we can see our outputs here. So we can see that there's really been no change on the chart. So as soon as the closing price moves below the SMA by any amount, we're getting 100% confidence that we're below the SMA or above it, right? As soon as the closing price moves above it by any amount, it's giving us 100% confidence. Well, let's find out why that is. So if we look at our output, so when A, the closing price, is greater than B, the SMA, by 10 ticks, right, we want a 100% output. But also in this section down here, we have if the closing price is greater than the SMA by 0 ticks, we want a confidence of 100%, or we want an output of 1. So we still have by 0 ticks set to 1. So 0 ticks means any amount. So as we can see here on this bar, let me slide this over. So on this bar, the closing price is above the SMA by less than a tick, but it's greater than 0 ticks. And so our comparison has been met, or so this condition has been met, right? The closing price is greater than the SMA by 0 ticks, so it's been met. So our condition has been met with 100% confidence, and so therefore we're getting a 1 on the output. So if we want to truly be looking for a 10 tick difference, then what we have to do is we have to set this parameter to 0, because we're not interested in when it's 0 ticks of difference. We're only interested in when it's 10 ticks or more. So we'll set this to 0. And now you can see the output changes greatly on the long side. And we typically want to keep the same for the short side. So when A, the closing price, is less than the SMA by 0 ticks, we're not interested in that difference. So we're going to set this output to 0. And now we can see the short sides is now changed as well. All right, so let's use this bar as an example. So the grid on my chart, I should probably increase the grid so you guys can see it a little bit. Horizontal. 2. There we go. So the grid is spaced 10 ticks apart. So it kind of helps us with a comparing the relationships visually here. and so if we look, so what we're let me back up here. So we're looking, so now we have our output set up so that we're really only looking for a 10 tick difference between the two data sets, right? Between the closing price and the SMA. But as we see on the chart, we can see our SMA is essentially at 0.33 or 33 cents on the instrument, but the closing price is at 41 cents. That's less than 10 ticks. So what's going on? How come we have the chart shaded in the background? Well, because it's less than 10 ticks between the closing price and the SMA. What's going on there? Well, let's look down here. Let's look at BloodHound. So I'm going to mess with my indicators again. So if we look at the output of the solver, we have a 83% confidence, right? Excuse me, 0.8829, which I'm just going to round that off to 0.83. So that's 83%. And so there's an 83% confidence that we're at our 10 tick requirement. So we're not at 10 ticks, we're at 83% of that 10 tick requirement. So what that's telling me is that we're 8.3 ticks away from each other. There's an 8.3 tick difference. And so the reason why the chart is shaded in the background is because of our threshold level. So you can see the green line here and the red line. Remember, those are our threshold values here. And right, so we have our threshold set. So that's what these thresholds do, is they allow you to build in some flexibility into your system. So instead of making your system rigid and requiring an absolute 100% condition being met on every single solver, if you have a bunch of solvers, you can say, instead of requiring all of your solvers to have their conditions met at 100%, you can say, well, out of all the solvers I have on my system, if I get 80% of all those solver conditions met, if I get 80%, that's close enough to take a trade, or that's close enough for my conditions to be met. And quite often, when traders are looking at their indicators and they're traded discretionarily, because we can't calculate all of our indicators and measure them with our eyeballs, instantaneously. That's kind of what we do. Is we look at our indicators and go, yep, that's close enough. Yep, my MACD is close enough. Yep, my stochastic is close enough. And so usually when we're reading a chart visually, looking at it with our eyes, I think it's fair to say that, what we're seeing is that if our indicators are doing what we want them to within an 80% kind of range, then, visually we're seeing our conditions being met. And so that's kind of why the threshold is set at 80%. So if you do need your solver's requirements to be absolutely met at 100%, then you could change your thresholds to, I would suggest just going to 99. So, and let's see what's going on. Do I have another window open? And, oh, I'm changing the wrong spot. Sorry. So there. So you could change it to like 99. So, right. So you could require your solvers to meet 99% confidence. And that's going to make it a lot more stringent. So I'm going to change this to 99, and also I'm going to make the let's see, yeah. I'm going to make the threshold lines a little easier to see here. So now, when I change the threshold to 99%, you can see this is not being shaded anymore, right? Because remember, our distance between the closing price and the SMA was it's what is it, 0.8? Yeah, it's 0.8 or 8 ticks. I'm sorry, not 0.8, but it's 8 ticks. And we're looking for 10 ticks. And now that our threshold requirement is 0.99, essentially we're only going to get the a signal painted on the background here when we're at 10 ticks. So let's go forward and see if any, there we go. So now our condition is met here to the downside. So we can see the SMA is up here at 34 cents, and the closing price is down here at 24 cents. So that's a 10 tick difference. And so now we're getting the background painted. Now the background shade is met, and we can see our confidence, right? The solver's output is 0.993. So it's 0.003 above or greater than our threshold requirement that we just set to 0.99. And so therefore our condition is being met. Well, actually, we're not at 1. The output solver is not at 1, so it's not 100% met, but close enough, right? Close enough. And so if we look at the output of the solver here, right, we can see that as the closing price starts moving up and gets closer and closer to our SMA line, right, we can see that the output of the solver gets closer and closer to 0, meaning that our 10 tick requirement is being met less and less. And so we can see on these couple of bars here, like this bar for instance, we can see the closing price is what, 1 tick away from the SMA. And if we look at the solver's output, right, the confidence output is 7%, 0.07. It's 0.07 or 7%. So if we're looking for a 10 tick, so to kind of expand upon this, if we're looking for a 10 tick requirement, but say we kind of want to know when it gets to 8 ticks, when it's getting closer to 10 ticks, so let's just say, you know, when we're really kind of getting interested when the difference between the closing price and the SMA, when the difference is greater than 8 ticks. So now, if we look at our output descriptions, so when the closing price is greater than the SMA by 8 ticks, right, our confidence output is going to be 0. And so from 8 ticks to 10 ticks, so from 8 ticks to 10 ticks, the confidence value is going to range from 0% confidence to 100% confidence. So now there's only a 2-tick difference in our range here. And so that's going to change the, you know, the analog output of the solver dramatically. And so, okay, so let's kind of take a look at this right here. We'll take a look at this bar. So we can see our SMA is at 34 cents and our closing price is at 28 cents. Right? So that's a 9-cent difference, or a 9-tick difference. And if we look at our solver's output, we're at a 60% confidence. Right? So we can see that the, you know, this 9-tick difference, and remember, NinjaTrader is rounding off these flags. It's rounding off these flags. So this difference between the SMA and the closing price is just over, it's just over 9 ticks, right? And I know that because our solver's output is at 60%. Right, so 9 ticks, to look at this, 9 ticks is exactly halfway between 8 ticks and 10 ticks. So 9 ticks would be a 50% confidence. But we're at 60%, so that tells me that, you know, the difference between our two data sets is just over 9 ticks. And if we take a look at the next bar back, it still shows, right, this on the chart, it still shows that there's 9 ticks when you round off the values, right? We can see that there's still a 9-tick difference between the closing price here and the SMA. But obviously you can see that the closing price moved quite a bit here. So even though the flags here say 9 ticks, but it's actually probably a little less than 9 ticks. And our solver's output here is at essentially 29%. 29%. So if 8 ticks is 0%, and 10 ticks is 100%, right? 28% is going to be just over 8 ticks. So really, I kind of know that the difference between these two values of our SMA and closing price is just over 8 ticks. But really, what using two different amounts here, what that's really doing is it's kind of constraining, right? You can see it's constraining this solver's output. So it only starts giving us an output when we're greater than 8 ticks. Versus if we go back to 0 ticks, right, we can see that our output is a lot more liberal from this solver. And so you know, putting 8 ticks in here, or I'll put 7 ticks, or actually I'll put 5 ticks, just kind of easier to do the math with 5 ticks, right? And so it kind of constrains our requirements again. So that way, if we're using like a threshold of 0.8, you know, using a 5-tick minimum or an 8-tick minimum, you know, kind of makes the requirement stricter. All right. With that, let's see. I'll take a little break here, and I see there's a couple of questions come in, and then I'll move on to the threshold solver. So just give me a moment to read these. So Roger's asking, what is the increment on the x-axis for each increment on the y-axis? Well, Roger, I think I understand what you're saying, but the way that you wrote it literally, there is no relationship. You know, the x-axis and the y-axis are totally separate relationships. But to answer your question directly, the increment on the x-axis is always 1. From one bar to the next bar, that value is always 1. So with the x-axis essentially always being 1 from one bar to one bar, when you're calculating a slope, essentially the x-axis becomes kind of a null point, you know, because it's always 1. So therefore, when you're measuring slope, the only thing that ever changes, right, the x-axis never changes because it's always 1, a value of 1 from one bar to the next bar. So the only thing that ever changes is the y-axis, the price. So that's why calculating slope on charts is far easier than if you're doing engineering, you know, because the only thing that changes on a chart is the y-axis. So that's what. So it makes it easier to say that, you know, if you're looking for a slope of 2, then essentially you're just looking for your data series or your data set to move 2 ticks or more. All right, and Darren has a question here. Is it possible to somehow use either the open, high, or low in a comparison? It would be very useful to have it as an option instead of close. Yes, Darren. So let me actually show you the proper place to find that. So on the BloodHound interface, I am going to bring up the video tutorials. And I actually did a tutorial video on accessing price data. All right, and if I scroll down near the bottom down here, as soon as the chart finishes loading up, there, tutorial number 5. And I'm trying to highlight this here. That's right. For some reason you can't highlight these, but the title here, Getting Price Data with Chameleon. So we have an indicator that comes with BloodHound down in the SI section. So you can see you have SI BloodHound, and then right below it is Chameleon. If I add Chameleon on here, right, you can see it has all of the different price data, and also you can see at the end of the price name there's this designation SMA and the designation bounds, right? So this video kind of explains what these designations mean and how they're used, and it also, you know, obviously it covers the parameter setting here as well. So let me remove that. And in this, nope. And in this video, I do some simple, you know, comparisons of price and stuff like that to kind of explain how to use it in the example. And then also, you see here on our menu bar on the right, you'll see under additional indicators we have the chameleon right there. So that's the written documentation for it. All right. So good topic there, Darren. Thanks for bringing that up. So, all right. So with that, I will continue on to the threshold solver. All right, so with the threshold solver, I am going to, let's see, this is the stochastics. Let's see. Yeah, I'll use the stochastics here to, well, actually, I think, yeah, I'm going to use the MACD. I think it'll create a simpler example to follow. So let me move the MACD up. There we go. Stretch this out. And okay. So here I found a nice location that would be easier to kind of create an easy example here. So we can see that our MACD is kind of ranging from, you know, negative 0.1 up to 0.1. And we have our zero line here in the middle. And so the default settings for the threshold solver, actually, before I get going, let me switch this over to the MACD instead of the SMA. And I'm going to be looking at the MACD value here. So that's what this light blue line is, the MACD value. And default settings, all right. So what I'm going to do is, you know, we'll start with just a simple threshold comparison of 0, and then I'll compare it to 0.1 and negative 0.1. So now if you haven't watched the threshold solver video yet, one key point to get the threshold solver to work correctly is your values need to range in order. So threshold A needs to be the highest threshold value, and then it needs to descend in order down to the lowest value. Right? So E has to be the lowest value. So if I put, you know, so if I put negative 2 in here, the threshold solver essentially is not going to work correctly, right? Because negative 2 is less than negative 0.1. So this negative 2 would kind of mess up the logic in the threshold solver. So the negative 2, to get this to work correctly, I'd have to put negative 2 down here and negative 0.1 there. But even that wouldn't work because 0 is greater than negative 1. So really, 0 needs to go there, and negative 0.1 needs to go there. Right, so I can't have a 0 in between these two values. So all right. Actually, no. Let me start off with something simpler here. So we're just looking for a threshold of 0, of when our MACD crosses the 0 line. And so on the long side, if we're at A, and remember A equals 0, so if we're at 0 or greater, I want a long output of 100% confidence. And then on the short side, if we're at E, and once again E is the 0 line, so if we're at 0 or less, so in other words, if we're below 0, the 0 line, I want a confidence output of 1. And so there we go. So we can see that as long as the MACD is below our 0 line here, and let me make this even more obvious. There we go. And so right here at the crossing point, right, so the way this is set up is just simply looking for our indicator to be above or below, excuse me, above or below the 0 line. So now if I want to get into a little more advanced use of this, I could be looking for when the MACD gets above 0.05 or below 0.05. So to do that, I could put 0.5 up in A, and then leave these middle ones set to 0, and down here, negative 0.5. And our output is already set correctly. So we can see that when we're at 0.5 or greater, we want 100% confidence. And, oh, I'm sorry, I'm missing a 0. 0.05, 0.05. There we go. So when we're at 0.05 or greater, we want 100% confidence. That's what we're interested in. And when we're below 0.05, we're interested in that area as well. So we're looking for 100% confidence. And so here we can see, as soon as the MACD crossed above 0.05, we have our, let me slide this over here. Right, so we can see the long output right here is 1, telling us we're definitely above 0.05, and we can see here's our value right here, 0.0508. And if we step backwards to the previous bar, right, 0.047, right, is just below our 0.5 requirement. And so we can see the threshold solver's confidence is 94%, or 0.94. So we're almost at 0.5, but not quite. So we're 94% to our 0.05 threshold requirement. So if we're measuring from 0, the 0 line, to 0.05, we're 94% of the way there to 0.05. So we can see here how, like right here, this bar is where we cross the 0 line, and we can see our output is now positive to the long side. And we can see the greater the MACD gets away from the 0 line, the greater the percentage confidence of our solver. And of course, the same is true for the short side. So you can see as the MACD starts diving down, the closer it gets to negative 0.05, we can see the confidence output. It keeps increasing, right? So we're 46%, 51%, still 51%, 58%. So I'm looking at the solver's output here. Now we're at 71%, 88%, and then 100%. As soon as we cross that threshold value of 0.05, we're at 100% confidence. And so forth. All right, so if you are interested in kind of using the fuzzy logic, but you don't want to give your system this much leeway, you're really not interested when the MACD is near the zero line or whatever, then we can build in some constraints here. So let's see, let's put 0.4, oops, 0.4 and negative 0.04. And so now you can see we really, let's take a look at the longs here. And also, let me put a line on here. It's going to represent 0.04. All right, and there you go. There's a gray line that works good. Just going to find a different color here. Yeah, lime green. All right, there we go. The dotted green line represents 0.04. And so we can see as the MACD value ranges between 0.04 and 0.05, so now we're starting to get some output from this solver here. So anything less than 0.04, there's no output, right? And so that goes back to how we have the output section set. So when the MACD line is at 0, we have no output. And then when it's at 0.04, there's no output. But when the MACD ranges from 0.04 to 0.05, we're going to start ranging from 0% confidence to 1 or 100% confidence, just as we can see here. So let me back this up. We'll step forward, right? So we can see our MACD right here is at 0.38. Step forward here, 0.04223, and we can see our the solver's confidence output is at essentially 23% or 22.8%. And so now we can see the MACD output is at 0.046 to round it off. And our solver output is at essentially 60%, almost at 60%. And we can see the MACD is halfway between 0.4 and 0.5. And we're just kind of staying, the MACD is kind of hovering flat there. And eventually, there we go, and then boop, as soon as it crosses 0.5, then we get 100% confidence met. So So understanding this, relationship between your solver's, input parameters here and the output parameters is kind of the key link, the key concept of what BloodHound is kind of based on, right? So each of these solvers is trying to solve a different condition, right? So like the bar length, right? Obviously it's looking at the length of the bar. So in order to see that correctly, I would need to put it back on. Actually, I'm going to put it on high-low. There we go. So the bar length is measuring the high to the low. And kind of defaults to ATRs, but let me put it on something simpler, such as ticks. I'll put the other one on ticks. That's a little easier to see. So say if we're looking for a bar of a long bar of 10 ticks, right? And so we can see we have this range. So we have some input parameters for the length of the bar, and we can see we have an output section that ranges with that. And I can see my parameter didn't update for this, so let me just click off of that. There we go. So in our output section, when we're at or below 0 ticks, we're not interested in that. So our output's going to be 0, but when we're at or above 10 ticks, then we're interested in 100% output. And so, as you can see, the BloodHound output here let me stretch out BloodHound. So let me find a bar here that meets our requirements. Here we go. All right, perfect. So I can see this bar here ranges from 50 cents all the way up to 60 cents. So it's exactly 10 ticks. And our output from this solver is 100% confidence met. All right, so we're getting a value of 1 out, or 100%, when we're at 10 ticks. And so anything less is going to start ranging from 0% up to 100%. So the way I have this set up, if I just look at BloodHound's output, so I can see our output of this solver is at 80% or 0.8, 80%. So that tells me that the bar length is 8 ticks long. And so if we look at this bar here, we're ranging from 52 cents up to 60 cents. So that's 8 ticks, an 8-tick bar. And of course, if I go find a real short bar like this, right? So I can see the output of this solver is 40%. So that's telling me, the way I have this, since I'm looking for a 10-tick bar, 40% of 10 ticks is 4 ticks. And if I look at this bar length right here, we're going from 61 cents up to 65 cents. So it's a 4-tick long bar. So once again, matching, matching your, your parameter requirements of what you're looking for with the output is what's critical. So if I want to constrain this more, say like I need to look for a bar that's 5 ticks. I'm really only interested in when a bar gets to 5 ticks. And then ranging from 5 ticks to 10 ticks or more. I mean, really, the way I have my output set up is that really I'm only interested in a bar that's 10 ticks or more. But I'll just say, I'm starting to get interested when the bar length at least gets to 5 ticks or more. And so now we can see these bars, this bar here, which was 4 ticks, there is no output. So it's less than 5 ticks, right? So anything, oh, let me click over here. So when we're at or below 5 ticks, there's not going to be any output. So I can see all of these bars here probably are 4 ticks long. And then we get to this bar, which is 8 ticks long, and we can see our solver's output is at 60%. So 8 ticks is 60% between 5 and 10. So, right, so 8 ticks is 60% of 5 to 10. So, all right, well, with that, looks like I either put you guys to sleep or I did a really great job because I don't see any questions. So, all right, well, guys, with that, I'm going to wrap it up. Time to go, and I hope this enlightened some of you new users of BloodHound. So this is probably old school for some of you veterans in the room, but I know sometimes once in a while it's good to rehash this stuff just for a little clarity, and sometimes you pick up something that you didn't realize before. So, all right, well, thanks for all the thanks, guys, and have a great weekend. And once again, I'm the one posting these workshops, and typically I get them up by Sunday noon to Sunday evening is usually when they finish uploading to YouTube. So, all right, guys, we'll see you next week.